Let's continue in lesson 26 with fractions, this time adding and subtracting unlike fractions. We have several steps that we have to cover. The first thing we have to do is decide on a least common denominator. Remember, when we're adding and subtracting fractions, we must have a common denominator, not when we're multiplying or dividing, but when we're adding and subtracting. So we have to decide on an LCD, and then we have to convert all the fractions to have equivalent LCDs or common denominators, and then we can just follow the steps that we've already had for adding and subtracting like fractions. Take a look at example number 1. There are two fractions there, 5/6 plus 1/12. First we look at the denominators, 6 and 12, and we say, what's the smallest number or the least number that both of those would evenly divide into? Well, it looks like our LCD is already one of our denominators. We're going to be able to use 12 as our LCD because 6 will also divide into 12. So it's always nice when that happens. This means we only have to convert one of the fractions. We can leave the second fraction just as it is, 1/12. And of course, the operation in the middle stays the same. And then we only have to convert 5/6 to something over 12. Well, to get 6 to become a 12, we had to multiply times 2. So we'll have to multiply the 5 times 2, and we will have 10/12 is our equivalent fraction. Then all we have to do is write our problem with everything else in the numerator and our common denominator, simplify the numerator, and we have our answer, which is 11/12. Let's look at example number 2. This time our denominators are 3 and 4. They have absolutely nothing in common. They don't even have any common factors if you factor them to primes. Therefore, the way we're going to get our LCD is we would multiply those two denominators together. In other words, we'd say 3 times 4 is what we're going to have. Once again, our LCD will be 12. But this time, we're going to have to convert both fractions to something over 12. So I'm going to write the problem down. I'm only leaving the numerators blank so I can do the conversion. How would I get a 3 to become a 12 in this first fraction? Well, I multiply it times 4. So I'd have to multiply the numerator times 4, and that would give me 2 times 4, 8 for my numerator. In the second fraction, how did I get that 4 to become a 12? Well, I'll multiply it times 3. So the numerator has to be multiplied times 3, and that'll be 3 times 1, or 3 12ths. Now I have a common denominator of 12. Everything else goes in the numerator. I simplify my numerator, and my answer is already reduced. It looks this way, this time it is, and it's 5/12. In example number 3, we've got a whole number that we're going to subtract a fraction from, but we're always going to look at it as if it's a fraction by putting it over the number 1. We look at our denominators of 1 and 20, and we say they have nothing in common, so once again our LCD would be multiplying the two together. Our least common denominator would be 20. Our second fraction is okay because it has the denominator of 20, so we just say y/20. Our first fraction we're going to have to convert. How do we get a 1 to become a 20? Multiply times 20. So we'll have to multiply our numerator times 20. 5 times 20 is 100. Now let's write the fractions over the common denominator of 20. Everything else goes in the numerator, 100 minus y. And this is as simple as we get. We can't combine these terms because they are not like. And remember, you can never reduce a fraction. You can't reduce that 100/20 because we still have subtraction in the numerator. If it was 100y or 100 times y, we could reduce. But subtraction or addition in the numerator stops us from being able to reduce that fraction. Let's take a look now at example 4. Our denominators, 5 and x, have nothing in common. How do we get a least common denominator? We multiply the two together, and we have 5x. Let's convert both fractions to something over 5x and leave our operation alone in the middle. 5 would have to be multiplied times x to give me 5x, so I'll have to multiply 2 times x, and that gives me 2x. X, to get to 5x, is going to have to be multiplied times 5. So my numerator of 3 has to be multiplied times 5, and that gives me 15. Now I can write everything over the common denominator of 5x, and I have in my numerator 2x plus 15. Once again, they're not like terms, so I cannot combine them, and I can't reduce because I have addition in my numerator. It's not all multiplication. So that's the simplest form, and that is the answer. Number 5 has 3 denominators, 3 fractions. We're adding and subtracting. I have 5, 4, and 2. Now, if I take those down to primes and I look for what they have in common, I'll find that my least common denominator is going to be a multiple of 5, 4, and 2. The smallest one is going to be 20. You could probably figure that out by taking the largest denominator, which is 5, and looking at the multiples. 5 times 2 would give us 10, but 4 will not evenly divide into 10, so that one didn't work. 5 times 3 would give us 15, but 4 and 2 don't divide into 15. 5 times 4 is the next multiple, and 20 will evenly divide each of them, and so that's a quick way to be able to tell when we have small numbers like this. So once again, my denominator of 20, I'm going to have to do conversion with all 3 fractions. So let me just write down my denominators and my operations in the middle. I'm going to take this 6 over 5. 5 had to be multiplied times 4, so 6 will have to be multiplied times 4. It'll be 24 over 20. 4 has to be multiplied times 5 to give me 20, so I'll have to multiply the 3 times 5. That gives me 15 over 20. And 2 has to be multiplied times 10 to give me 20, so 1 will be multiplied times 10. That gives me 10 over 20. Let's write all of this over that common denominator of 20. What do we have? 24 minus 15 plus 10. And when we combine these terms, we say 24 minus 15 gave us 9 plus 10. Well, my answer is 19 in the numerator, and the common denominator is 20. Number 6, one more problem. LCD for this one is one of our denominators. Look, 10 will work. All 3 of those numbers will evenly divide into 10, and that's the best case scenario. If you can make that happen with your fractions, it's the best thing to do. So we leave that first fraction alone. It doesn't have to be converted. The second one, we need a denominator of 10. The third one, we need a denominator of 10. For the middle fraction, I'm going to have to multiply the 2 times 5 to get 10. So I'll multiply 1 times 5, and I have 5. For the third one, 5 times 2 gave me 10. So x times 2, I flip that around and have 2x. Now, over the denominator of 10, I have 9x minus 5 plus 2x. Remember, everything else except the denominator goes in the numerator, including the operations and the signs. So what can I combine here? Well, I've got 9x and I've got a positive 2x. That gives me 11x. I still have a minus 5, and it's over the denominator of 10. Can't reduce because I have subtraction in my numerator.